So today, April 27th, we will be explaining The Chemistry of a Battery by Luke Fuller and McCabe Haggerty.
What is a battery? A battery is a device that consists of one or many electrochemical cells that also have external connections in order to power electrical devices such as mobile phones, electric cars, and even remotes for a TV or gaming consoles. In today's world, almost every kind of device has batteries incorporated to help it run. Batteries come in all types of shapes and sizes, and even with different designs. Batteries can be about as small as the fingernail on your pinky finger, and also the size of rooms to power and provide large amounts of power to a certain source.
So, how does a battery operate? A battery has two terminals when supplying energy to a source. The positive terminal is called the cathode, and the negative terminal is called the anode. The anode is the source that electrons will flow into an outside electric circuit back to the cathode. Essentially, the operation of a battery works like a cycle of electrons moving through the battery over and over. This cycle is demonstrated in the illustration below. So we see that the Na plus 1 is the blue and the Cl1 minus is in the red, and it's like a big circle as the energy is transmitted through the batteries.
The history of a battery. The first electrochemical battery was developed in the year 1800 by an Italian physicist named Alessandro Volta. The design resembles almost nothing of what batteries are today, but Volta's design could create a steady electric current for a good amount of time. The battery consisted of a stack of copper and zinc plates which were separated by brine-soaked paper discs. So you can see here Volta, that's his portrait, and then that's also the first design of the battery.
Looks pretty old. So we have a few examples of the different types of batteries and what they do and what they're used for. So the first battery we're going to talk about is the one of the most common ones that we use in our daily life, but the lithium ion battery. The lithium ion battery is usually used for powering portable electronics like phones and portable phone chargers. They are also used to power electric vehicles such as scooters, electric motorcycles, electric cars, and others. That's and the Tesla cars use lithium ion batteries and like drones and stuff. Um, in fact, companies are starting to use them in aerospace projects. The first of the lithium ion battery was developed by a man named Arika Yoshino in 1985. In these batteries, the lithium ions travel from the anode through an electrolyte to the cathode, and back through this process we're on. These batteries have high energy density and a low self-discharge. The low self-discharge can in some cases be a hazard because they contain flammable electrodes. That's why when you fly on airplanes, they always want you to like carry them on because they can always explode and cause a lot of harm. So we have a few formulas here. So the anode is LiC6 yields C6 plus Li plus E minus. And now the cathode is COO2 plus Li plus E minus yields LiCOO2. And so now you have your overall reaction, which is LiCO2 C6 plus COO2 plus Li plus E minus yields LiCOO2 plus C6 plus Li plus E minus.
Now our next example is the alkaline battery. Alkaline batteries are the most popular batteries in the United States. They contain zinc and manganese dioxide, MnO2. This mixture can be toxic, but there's not enough in these batteries to cause harm. Alkaline batteries are commonly used to power MP3 players, CD players, cameras, toys, and lights.
Alright, we're not going to read these formulas, so we don't, since we're on some time constraints, but feel free to pause the video here. So the next one was mercury batteries. So mercury batteries are non-rechargeable batteries that have a primary cell. They use a reaction between mercury oxide and zinc. They are commonly formed in the shape of a button and are used in hearing aids, calculators, and watches. They become widely used in 1942 for military tactics during World War II. They provide a steady voltage output and last for a longer amount of time than most batteries. So these are used for like really small tight spaces that are really lightweight and have a lot of voltage. And then we have the reactions below, but feel free to pause the video.
And here we have our works cited. You can check those out to refer to more information. And here's a picture of our attempted experiment, which did not go very well. And we're going to explain that in the next slide.
Alright, so we're doing the chemistry of a
Potato. It's used as a battery. So we're gonna put the light bulb on.
So we've got 2 potatoes,
Zinc screws,
copper wire, and a light bulb. So we put the screws in here. Then we had the copper wrapped around the screws.
As you can see here, we're
and then we've got
putting
on
the
2
screws on.
potatoes like that.
We'll take our hot glue gun.
We'll hot glue gun this. Let that dry.
Blow on a little bit.
Don't want to get burnt out here.
Put in a new stick.
Yeah, I gotta make sure you have some hot glue in here. So now we're gonna we put the first one on the black part of the light bulb.
Now we're taking the other one to the side.
Now we'll do this one on the side.
Apply our hot glue. Bam. On there.
So we've gotten to this point, and
it just does not work at all.
Normally the light bulb is supposed
Lights
to
at
light
this
up,
point.
and
There is heat by the hot glue.
and the rest of the video will show you an actual demonstration and how it can work.
Okay, get rid of it. Now here's our actual video of someone else doing the experiment correctly.
So here they have their light bulb, and I'm taking a copper wire, putting it to the black end of it, and then they'll hot glue it on there so it doesn't move. And they'll let that cool and dry. I'll take the other wire and do it to the silver side. That's kind of like the ground. And then I'll take the light bulb, hot that ground to a flat surface so it doesn't move. And I'll take a potato and hot glue gun that to a flat surface. take the other potato and do the same. Now we'll take 2 screws and put a screw in each potato. We'll screw that in. Do the same to the other potato.
And now, as you can see, they're wrapping the copper wire around each nail. Now I'm going to touch the other wires in the nail and the bulb will light.